All right, so here's the help video for 8.6. Again, if you have questions, always feel free to ask in class. And note, the formulas you might need are on page 596. Barring things that are obvious, like the quadratic formula or basic area or perimeter formulas, I would give you these formulas on a quiz or a test. I wouldn't expect you to necessarily remember the volume of a cone or a sphere, etc. So number 1 talks about a spherical balloon that's being inflated. So I know my formula, 4/3 pi r cubed. I take my derivative right away. Again, we're working in terms of t, and there are no t's in this equation, so this is implicit differentiation. From here, this is going to tell me what values I need to look for, dv dt, r, and dr dt. If I read the problem, I can see that I'm increasing the volume at 6 feet cubed per minute, so I know that I've got this 6 value, and it's positive. The radius, they tell me, is 10, which means that what I'm looking for is the rate of change of the radius. So I substitute in my given values, simplify, and then divide both sides by 400 pi. Without a calculator, you would leave it as this 3 divided by 200 pi. If you had a calculator, you'd be welcome to give the decimal. And then since I'm talking about the radius and its rate of change, I know I'm dealing with feet per minute. Number 2 talks about a ladder sliding down the wall. Now, like we discussed, if you can already identify that one of these values is going to remain constant no matter what, in other words, the height of this ladder, you can plug it into the equation right away. Otherwise, my recommendation is establish what the formula is that you need, take its derivative, and that's going to tell you all the different things that you should know. By the time we look through the 1, 2, 3, 4, 5, 6 separate values we're now presented with, there should only be one remaining unknown. And in this problem, it's one of the few times that we see that there's a known unknown, something that we're supposed to recognize. Namely, that the ladder is not going to change in length or height, so its derivative is 0. The other value we aren't given explicitly is the base value. Well, I can use my Pythagorean theorem to find that base value. What's the height of the ladder? What's the height it is on the wall at the given moment? And then we can solve for the base. Notice that in this, I'm able to also cancel 2 from every piece, or divide 2 from every piece. So when I go down to substituting in, you'll notice those 2's are gone. If you don't do that, it's fine. It just saves us one step. The other minor detail in this problem to recognize is it says that the ladder, is being pushed towards the wall, so the length of B is shrinking. And if the length of B is shrinking, I know that I need a negative derivative. I substitute the values I have, simplify, and then follow through my process of solving. Since this is a rate, I know I've got to compare a value to time, and in this problem it was feet per second. Number 3 talks about the area of a circle, so I know that I need a equals pi r squared. I take my derivative, and again, this lets me know that I've got 1, 2, 3 values, so by the time I finish reading my problem, I should know at least 2 of those values. It turns out that they tell us the rate of change of the radius is 0.5. They also tell us the radius is 0.5 by telling us that we have a 1-inch diameter, leaving the rate of change of the area to be the last thing I need to solve for. Substitute in my values. Since I'm talking about area, my units are going to be inches squared. Since I'm talking about the rate of change of the area, inches squared per minute. Number 4 is a cylinder problem, and as we discussed in class, in a cylinder problem, the radius does not change. Once we can establish that the radius does not change, we can actually substitute that value in and solve. Now, next year, when these things might not be as obvious, you'll also have more rules. Right now, we don't have what's called the product rule that would allow us to take the derivative of pi r squared h without substituting in that radius. So when dealing with a cylinder problem, you should always be able to substitute in your radius. From there, I take my derivative. That tells me that I should know at least one of these 2 values. Notice that they tell us the volume is dropping. It's leaking, so my rate of change of volume is negative. And then I'm just left to solve by dividing both sides by 100 pi. I'm talking about rate of change of height, so I'll have feet per minute. And finally, number 5. So number 5, again, you might recognize that there's a value that's not going to change in this problem. That's the 70 of how far this person is from the intersection. But the other known unknown that we're supposed to recognize is they tell us the rate of change of the train, and then they tell us how much time has elapsed. They tell us that 4 seconds have elapsed. So I know that the distance the train has traveled from that intersection is 240 meters, because 4 times 60 is 240. From there, I can use these values to find my missing value of d, the distance between myself and the train, or the person in the train. It's best to use this exact value as you work through the problem. You don't want to round too early. But from there, I can substitute in all my knowns, simplify, and in this one, I don't think having the square root of 52,700 is that useful, so I actually simplified and rounded to the 3 decimal places. All right, I hope this helps. Again, if it doesn't, always feel free to ask questions in class. Happy to answer them.